As you can see here, we've got another sketch or diagram of the submerged arc welding process. Not a lot of really good live action photos of the submerged arc welding process. It's not really a fantastic spectator sport as far as the welding world goes. It's not like watching somebody do an open root 6G pipe weld or something cool like that. It's relatively benign. I don't know if that's the word, but it's not super exciting, kind of like watching paint dry. But it is an important process because it's got such high deposition rates and you can make such beautiful welds with it that'll X-ray. So basically the whole process boils down to an electrode wire, a chunk of barbed wire, and you're putting it under some sand or some kitty litter and you're running electricity through it. And I know somebody's probably going to flip out and tell me I'm wrong, but that's the basics of this process. The flux is more or less looks like floor dry or kitty litter, and the wire is just a big spool of wire. And so the process principles: submerged arc welding takes place beneath a flux covering without spark, spatter, smoke, or flash. The electrode and the weld pool are completely covered at all times during welding. The flux makes possible these special operating conditions, which distinguish submerged arc welding from other processes. Should be noted, when cold, the flux does not conduct electricity. Therefore, the welder must establish a conductive path for starting the arc. This can be done by scratch starting where the electrode touches the base plate, or by burying some steel wool in the flux at the starting point. In the molten state, the flux becomes highly conductive. Once the arc is started, the heat produced by the current causes the surrounding flux to become molten. This forms a conductive path which is kept molten by the continued flow of welding current. The buried arc of the flux is melted. The buried part of the flux is melted. The visible part remains unchanged in both appearance and properties and can be reused. All currents and polarities are used, depending on the desired penetration, bead shape, and whatnot. Reverse polarity provides the best bead shape and penetration, while straight polarity gives higher deposition rates but less penetration. Alternating current provides penetration somewhere between the two and is preferred for multiple wire welding setups. The fused flux is chipped off the weld and discarded. So, giving you a couple of different spins on this, things I've pilfered from, like I said, mil-spec handbooks on welding, Army manuals, Navy manuals, but that's the gist of the process. Again, gas metal arc welding. This is a definition. Gas metal arc welding is an arc welding process in which the heat for welding is developed between a continuously fed consumable metal electrode and the workpiece. As the metal electrode is fused by the welding arc, it becomes the filler metal for the weld deposit. Protection from atmospheric contamination, mainly oxygen and nitrogen, of the electrode, the metal in transit, and the electrode to the weld puddle, and the adjacent heated areas is achieved by a shielding gas, or a mixture of gases that flows from inside the nozzle to the electrode holder. GMAW is considered as a semi-automatic process when the electrode wire feed rate is the only mechanically controlled feature of the process. Manipulation of the electrode wire holder / gun is completely controlled by the operator. Machine welding with GMAW is a mechanized process, but one or more controls require attention and adjustment by the operator. Automatic GMAW involves fully mechanized equipment, such as robots, that require a minimum amount of observation and adjustment by the operator. However, most of the information we're going to cover in this is going to be restricted to the semi-automatic process. Gas tungsten arc welding is an arc welding process in which the heat for welding is developed by an electric arc maintained between a non-consumable tungsten electrode and a workpiece. Protection from atmospheric contamination of the tungsten electrode the filler metal, the weld puddle, and the adjacent heated areas is achieved by a shielding gas, usually inert, argon or helium, that flows from inside a cylindrical cup that surrounds the electrode. In a majority of applications, gas tungsten arc welding is a completely manual process where the filler metal is fed into the weld puddle by the operator as it is required. In this slide, you can see a bigger sketch of the self-shielded flux core arc welding process. In this drawing, you can see where there's the decomposition of the flux that is contained inside the tubular wire. It's getting cooked down in the arc, and it's giving off a shielding composed of vaporized and slag forming compounds, and this protects the liquid weld pool from oxygen and nitrogen, which would cause all kinds of deleterious effects on our solidified weld metal if it went that direction. This sketch is from a military manual, but it shows the gas shielded flux core arc welding process. You can see the difference here is there's an additional component, which is the gas nozzle. The gas nozzle helps bring gas shielding to the weld pool, and it keeps the oxygen and nitrogen out of the weld pool. You've also got the flux in the interior of the flux cord wire or electrode, and it's burning off and also providing a slag covering that's helping to shield the molten weld metal as we're depositing weld metal into our weld joint. So that's the main difference. One has an additional gas shielding component to it. The self-shielded flux core process doesn't. Transferred arc process. The arc is formed between the electrode and the workpiece, which is positive, the electrode's negative. In other words, the arc is transferred from the electrode to the workpiece. A transferred arc process high energy density and plasma jet velocity. For this reason, it is employed to cut and melt metals. Besides carbon steels, this process can cut stainless steel and non-ferrous metals where an oxyacetylene torch does not succeed. Transferred arc can also be used for welding at high arc travel speeds. Before production welding is started, a detailed welding procedure specification shall be established and qualified to demonstrate that welds with suitable mechanical properties such as strength, ductility, and hardness and soundness can be made with the procedure. 2 pipe lengths, full joints, or nipples shall be joined by the following all the details of the welding procedure specification. So this is basically telling you what you need to do in regards to 12.2, and it's very similar to section 5. So except that we're just doing it with a mechanized process as opposed to doing it by a hand process. But it's pretty similar. So I'm not going to go on a super deep dive into this one. And the rest of section 12, it just tells you that, the records you need to do, welding procedure specification, essential variables, qualification of equipment and operators, records of qualified operators. It just lines everything else, and it's pretty similar to what else we've covered in this welding code. But this is just specifically for mechanized welding. And this code splits out mechanized welding and hand welding into 2 different, menus or criterias or little universes. So, summary, we just covered, did a quick overview of the different welding processes, and then the rest of it is all very similar to whatever else we've done in the other sections, especially section 5 of this welding code, API 1104.